Good morning, good afternoon, good evening, good middle of the night, whenever you're watching this. This lesson is on polynomial graph behavior, so this is what's going on with the graph. This is a great reference lesson. There's not going to be a bunch of examples on this lesson though. So what we're going to do today is you're going to learn about graphing polynomials, sign analysis, and parameter changes with graphs. So that's what we're going to work on. And we're going to build on the information that we already know from previous graphs. So we're going to start with something we do know. And the first thing that we're going to start with is reviewing. So remember when we were in the quadratic unit, the solutions are called roots, x-intercepts, or zeros. So if you hear anything mentioned about roots, x-intercepts, or zeros, they're talking about what's crossing the x-axis. So quadratic properties. Remember, when you're asked to solve for x, and that ended up being where the graph crossed the x-axis. And that's where you could have three possibilities that could happen. So these are the three possibilities. We could have that the quadratic equation crosses twice, and we would have two solutions. I'm going to go for pink. Been using blue a lot. One at 0, 0, and one at 0, 4. So that would be where it would cross, or that would also be where the solutions are, x equals 0 and x equals 4. Okay, and that happens because the vertex is below the x-axis. Or it could be, it just crosses. All right, so, and that would be crosses. So that would be the terminology that you would use. So cross. Now, if the quadratic is squared and we don't have any vertical or horizontal shifts up or down, and notice how it's just going to be squared. So this is going to be, this quadratic is tangent to the x-axis, meaning that there's only going to be one solution, because if we were to solve this out, we would have a repeating x value at x equals 2, and so therefore it would be tangent, because it would kind of go down and bounce on the x-axis and then come back up, but it does not cross into the fourth quadrant at all. It stays in that first quadrant. So let's go ahead and take a look. So that would be tangent. Okay, now if it never touches the x-axis at all, okay, this is going to be no real solutions, and this is going to be our imaginary solution, and we talked about that as well. So you might end up with a complex number for the solutions, and we'll talk about that later on, but we would say no real solutions. All right, so there's a special relationship when a quadratic vertex is on the x-axis, like g of x, so it's talking about this graph right here, equals x minus 2 squared. The x-axis becomes tangent to the graph. Now remember in geometry, when you had a line tangent to a circle, that means that it would approach the circle, touch the circle circumference, aka perimeter, to the center, and then continue on. So it would never cross. So that tangent is the same vocabulary word we're going to use here when we're talking about a parabola approaching the x-axis, touching, and then going back up. It's also and we're going to have two solutions there as well. Okay, so linear functions, how many times does a non-vertical line cross the x-axis? Okay, and that would be only once. Okay, I think that should say actually horizontal now that I'm looking at it. Okay, but I just noticed that. Notice that the line crosses the x-axis, so this would be a cross. With a cubic function, how many solutions does r of x equal x to the third half? And that would just be 1. It crosses once. Okay, and this cubic function also crosses, is called a point of inflection. So notice how we're going to end up having, because it's cubic, okay, it reflects about itself and then it changes. So if we were to actually rotate this, 180 degrees, it would be symmetric about itself. So this is going to be our point of inflection. And I apologize, I just referred to it as crossing, but it does cross, but it also has a symmetrical kind of way about itself. I am a loss for words at the moment. All right, so when it's cubic, that would be a point of inflection. So we've got 3 vocabulary words: crosses, point of inflection, and tangent. So those are the vocabulary words we're going to use to describe what happens when the polynomial crosses the x-axis. All right, so we're going to start off with a polynomial function that has been factored, and we'll be working with factored polynomials when we're graphing them by hand. Based on what you know about linear, quadratic, and cubic functions, we're ready to graph this factored polynomial. Okay, I'm going to show you the easiest way to graph it first, and then we're going to go ahead and talk about sign analysis for when you're not sure what's going on with the graph, and you can test points to see if it's going to be above or below the graph, and therefore you can go ahead and graph it using just plotted points, because algebraically that is the best way to do it. But we already know some in-behavior characteristics from the last lesson and from this lesson. So let's go ahead and talk about different parts of it. Okay, so for the first step, you're going to draw an x and y axis on your paper. The y-axis doesn't need to be that big because we're just sketching, and we're actually not going to focus on how long our maximum points are, or minimum points, relative max, relative min, because today we're going to focus on the x-intercept and where the solutions are, the x-intercepts. Okay, so the next thing that we're going to do is we're going to find and plot zeros on the function, just the points. And then we're going to solve for zeros. We're going to set each factor equal to 0. Okay, so this first one is x squared. Okay, now x is really the factor. And when we say squared, remember that's going to be one of our tangent. So this is going to be tangent at that 0, okay, and x equals 0. So I know at that point it's going to end up being tangent. All right, now the next one is going to be x minus 1. Now that's a cubic, so when it's cubic, that's going to be our point of inflection. I just need to set the inside binomial equal to 0, because if the very first step, here I'll show you the very first step, is if it's cubic, we need to solve that, and the first step is to go ahead and cube both sides. That looks like a mess. I'm going to start over. So we know it's a point of inflection because it's cubic. So we have x minus 1 cubed equals 0. First step is to cube both sides. Cube root. Cube root of 0 is going to give us 0. These simplify out. We're left with x minus 1. Add 1 to the other side, x equals positive 1. So at x equals positive 1, we're going to end up with a point of inflection. All right, now our last factor, because it's already in factored form for us, is to the first power. So if you go up, you can take a look. Hey, if it's to the first power, that means it's going to cross. Okay, so if I know that it's going to cross, we just need to see what that x value is going to be, which in this case is going to be x equals -2. And that's going to cross. All right. Now, do you remember last lesson we talked about end value as far as, and also the a value? So if I were to multiply all of this out, there's no scales going on with any of these. This would be a positive graph. And we would take a look and we would have to add up all of the degrees, okay? And this would be 2 plus 3 plus 1. So it would be to the 6th degree. Sorry about that. Oh my goodness. So if it's to the 6th degree, it's even. So if it's even, remember this is going to tell us what's going on in the right. So it's going to end in the right. And since it's even, it's also going to be, hold on, pause for a second. Nope, I'm crazy. It's been a while since I've seen this. So if your leading coefficient is positive, that's going to tell you what's going on the right side of your graph. And in this case, it's going to go all the way to positive infinity. Now, if it is even, whatever your graphs are is going to be the same on the other side. So that really tells us what to do as far as how to graph this. Because when we come down, and this is just a sketch, you're going to cross at -2. You're going to come up and see, so if it says tangent, remember we're going to come up, bounce, and come back down. Because remember it has two values at x equals 0. And then the point of inflection is going to kind of have this wave to it because it is a cubic function. And like I said, this is just a sketch. Your sketches are going to look different than mine, and that's okay. We basically just want to make sure that we have the n values correct and what's happening at each x-intercept. That's what we're focusing on. All right, now the next step is we're going to go ahead and perform a sign analysis on this. Okay, don't let the word scare you. Sign analysis just means we're really checking to see and testing points in between those zeros to see if it's going to be above or below. And we're going to confirm what we did here. So with sign analysis, we start off by labeling our zeros. So our zeros in this case would be x equals 0, x equals 1, and x equals -2. So when we're performing this sign analysis, what we're going to do is do the x and y axis. That's going to be part of your step 2. I kind of added that part in there just to show you that we can do this without sign analysis. But now what we're going to do is go ahead and plot your points again. And -2. Okay, the first thing that we're going to do is we're going to talk about the domain between these points. So for the first one, we have the domain, and I'm going to do this in intervals. And we're talking about domain, remember, are the x values of our graph. So that's going to be all the way from -infinity to -2. But we can't include -2, because if I have -2 included and I'm testing -2, it's actually going to be 0, and that doesn't tell me if it's positive or negative. So the graph, I'm not going to know if it's going to be above or below. So we're just testing points. That's all we're doing for sign analysis. So we're starting off, my opportunities are from -infinity all the way to -2, but I can't include 2. So what I'm going to do is I'm going to test a point in between. So we're testing x equals let's say -3. So if I test -3 into my equation, the original equation, which I wish I wrote down so you can see it, is f of x equals x squared, x minus 1 cubed, and x plus 2 to the first power. Okay, so we're looking to see if it's going to be positive or negative. Ultimately, that's what matters. So if I have -3 and I square it, -3 squared, I'll write this one out, but in the future I'm not going to do that. -3 squared is always going to be a positive number. Anything squared is, or any negative is squared is positive. Now the next one is -3 minus 1 is -4, -4 cubed. So that's negative times a negative times a negative, which is always going to be negative. Next one is -3 plus 2. That becomes -1. And when I multiply that together, all three of these, positive times a negative times a negative, because remember, we don't care about the value, we just care about the sign. this is going to become ultimately positive. So I know my graph is going to be positive somewhere. See? Notice how it's positive up here. All right. So for the next section, which is going to be, I can go ahead and change colors. That's going to be this section right here. So my domain in this area, I can't include 2, negative 2. And I'm going to go all the way to 0, but I cannot include 0. So let's go ahead and see what the negatives and positives are going on with this. So when we test, I need to pick a number in between. I'm going to pick negative 1. Now I'm just going to focus on the negatives. So negative 1 squared is going to give me positive. Negative 1 minus negative 1 minus 1 is going to give me negative 2. Cubed is negative. Negative 1 plus 2 is 1, so that's positive. Okay, positive, negative, positive, it's going to become negative. So between negative 2 and 0, it's going to cross and become into the third quadrant. Let's see what happens after the 0, from 0 all the way to 1. Now in this case, I need a number in between 0 and 1. It can't be 0, can't be 1, so let's go ahead and pick 0.5. So we're just going to test 0.5. 0.5 squared is going to give us positive. 0.5 minus 1 is going to be negative. Negative cubed still stays negative, and 0.5 plus 2 is positive. All right. So positive times a negative times a positive gives me overall a negative value. So in between 0 and 1, I know that we are going to be in quadrant 4, or below the x-axis. Now let's go ahead and take a look. Remember, positive infinity is all the way out here. Let's go to purple. So from 1 all the way to positive infinity, okay, we can pick any point. We could pick 100 if we wanted to. I'm just going to pick 2 because that is on our graph. So when I test that, 2 squared is positive. And then 2 minus 1 is going to give me positive 1. Positive 1 cubed, always positive. And 2 plus 2 is 4, which is also positive. Multiplying all of those together is going to give me a positive solution. So I know it's going to end up being above the x-axis. Hey, check what we did out before. We have positive, then a negative, then negative again, and back to positive. That's exactly what happened with our graph. So if you can remember your in behaviors with the leading coefficient and the exponent of your leading coefficient, you would be able to graph this without using sign analysis. Sign analysis really allows you to see what's going on with the graph when you can't determine what the behavior is doing. Because what we're going to end up with, and I'm going to choose black here, we know that it's positive to when we're talking about negative infinity. So on the left side, it's going to go all the way to positive infinity for the range. It's going to approach negative 2, but because it needs to be in the negative, it's going to cross. And then we're going to go ahead and bounce, come back down. Okay, now with this x equals 1, we do need to remember that it is going to be a point of inflection. So when we have a point of inflection, it is going to kind of mirror itself. Whatever's happening on this side, that's not really a good example, is going to happen on that side. And it kind of does a little squiggle across the x-axis at 1. And then it's going to continue up to positive infinity. And it is even ultimately because we're at the 6th degree. So both endpoints are going to point in the same direction. All right, so that's sign analysis. We're going to go ahead and talk about parameter changes. So we've talked about parameter changes back in Unit 1. We also talked about it with quadratic formula. It's in every unit for the most part. Parameter changes that you know from the past. So putting on A, H, K together, this is in vertex form in a way if it was squared. In this case, this is cubic. So if we're looking at cubic equations, remember H changes left to right opposite of the inside of the parentheses, because when you set that equal to 0, you have to do the inverse in order to solve for it. The k shifts the whole quadratic or cubic or function up and down depending upon positive or negative. And a is going to talk about scale changes. So when we're talking about scale changes, it's really based off of the value of a. All right. Looks like I cut something off and I want to double check so I can fix it if I need to. That wasn't supposed to happen. Let's see if I can get that back up here. Whoops. I'm going to pause the video and fix this. There we go. Sorry about that. One of the slides went up and under another one. So when we're looking at this one, is going to be more of a reference video. So notice the leading coefficient is different and that it changes the look of the graphs. So if the a value, that value that's up in front, is less than 1, then it's going to be stretched out horizontally. So it's as if we were taking silly putty and really stretching it out. And that's going to be a horizontal stretch. If it's equal to 1, that's our parent function. And if it's greater than 1, that's going to go ahead and compress it horizontally. So that means it's going to kind of squish it and it's going to rise up higher. Or x values are going to be more, our y values are going to be more condensed. I said that right the first time. The x values are going to be more condensed. Sorry about that. Now, if it's positive or negative graphs, that's going to affected by the leading coefficient. If it's positive, the right in behavior will increase and be positive, which is shown here. Okay, if it's negative, it will reflect in the x value and the right in will decrease. So that means it's going to continue in the negative direction and will decrease as the function continues to go to the positive infinity x value. All right, so the h is the translation that shifts the graph left and right, but opposite the sign of the parentheses. Insiders always lie, just as a reminder. And a vertical shift, k, we talked about that as well. It's going to shift up and down, depending upon if it's positive or negative. So that's the parameters of that. If we're finding the degree of the polynomial, I talked about this up here a little bit when we were looking for the degree of the polynomial. Okay, we added all of those exponents together. So 2 plus 3 plus 1, it became a 6-degree polynomial. But if you don't have multiple binomials, then looking at the first one. So if we're looking at f of x, which is this equation right here, and we're just looking for the degree. Now remember, the degree represents the exponent. Okay, in this factored form, notice that when we expand the binomial, that the exponent of the leading term would be 3. So the degree of the polynomial would be 3. So this is a cubic polynomial. When we're talking about g of x, and we have multiple binomials going on, okay, so we have x squared, x to the first power, and x to the third. We could multiply all of this out, but I'm going to tell you right now, all you have to do is add them together. So then you would take 2 plus 1 plus 3, and that's going to end up giving you the 6. And if we multiply everything out, you would end up with a negative x to the 6th power, leading your polynomial, and you would end up adding different terms to that for g of x. And that would really help you out because it would be even, and this leading coefficient is negative. So this graph on the right side is going to be negative, and it's even, so the end behavior of the left side will also be negative, and it's going to do a whole bunch of fun stuff in between and turns and come back down. So it's going to go 1, 2, 3, 4, 5, 6. But the middle part's going to look totally different. All right, so that's for finding the degree of the polynomial. So you'll utilize this unique vocabulary when you're asked for certain things on your assignment. Do the best you can. Remember, there is always tutoring for Algebra 2. Also, ask each other some questions too. Have a wonderful day. Hope you guys are doing well. Goodbye.